Welcome back to another OVITO tutorial. Today I'm actually going to cover the Python scripting modifier. And really this is my favorite modifier simply because it gives you an amazing amount of flexibility. You can pretty much do almost anything. Really anything you can program, you can basically do. And it allows you to string together other modifiers that are built into OVITO so that you can do a lot more complex things. So that's what we're going to cover today. I'm not going to do anything complicated in Python in this video, and I'm not really going to, focus on telling you what the Python is doing too much. I can make some Python tutorial videos if you are interested in that, and if you are, just leave me a comment below. But like I said, in this video, we're really just going to be looking at how to use the modifier more than the Python part. So with that, let's jump on into OVITO. Alright, so first things first, we're going to load in some results that we can look at while we're playing with this modifier. And I'm going to use actually something that I did, I showed briefly in a previous video, kind of this multi-phase idea where I have FCC and BCC. I'm going to use that kind of as my demonstration here. So first of all, let's add a Python script modifier and take a look and see what we have. So you'll find it underneath the modification heading under modifiers, and you can just put add Python script modifier. Now when you go to the Python script modifier, the panel over here on the right is going to look different depending on what version of OVITO you have. So for example, I'm running OVITO 2.9. You can see here version 2.9, and in that one the Python script modifier looks like this. Everything that I'm doing I think should work in version 2.8 as well, but in that version the Python script will show right here in this panel instead of having this button that opens up a new window. I actually prefer this because I can make it bigger and not mess up the rest of my layout. So anyway, it doesn't matter. I do recommend getting the updated versions of OVITO though, because they're constantly adding new modifiers and new features, so it's worth updating if you can. Alright, so here's the default script that OVITO has. And there's one thing, the most important thing about this script is that this Python script defines a function called modify. And that is what the modifier will call every time it's updated. So basically every time you change the time step, or every time you change something before it in the modifier workflow, then it'll update this modifier and it'll do that and call modify. So basically everything that is defined in modify will happen every time the modifier is updated. So that's something important to keep in mind. Now this function takes three inputs. Frame, which is just an integer, it's the number of the frame. So for example, right now it would be 3. I actually need to change this to time series. Now it would be 0. And here it would be 32 and whatnot. Input and output are actually both data structures. They're OVITO's data structures that contain pretty much all the information about your system. So they're basically identical, if not identical, but the input one you can think of as the data structure that's coming into your function, and output is the one that's going to be leaving your function. So if your Python script, if your modifier is going to make any changes to your system or to what you're looking at, then you'll want to make those changes on the output data structure. And you'll see how that works as we get into it a little bit more. Okay, so then we have these data structures, input, output, but where's the data that we can get to? Well, some data is special, and so you get to it in special ways. For example, the number of particles is a special type of data, and so it has its own structure. And you can see input dot number of particles. That's just how you get that one. But most data is not referenced like that. Basically, there are two types of data. There are particle properties, and then there are attributes. So particle properties you'd get to by saying input particle properties, and then you would put a key name in here. And so if you had a particle property, well, something like position, it would be something like that. But that's not exactly it. But there's a way you can find out what it is. So we'll do this, and this will allow us to see what all the particle properties are. So when you're done, hit that run, and you can see we have particle identifier and position. Yeah, it is just position. So if we wanted to get, say, the position of particle number 1, then you would do that by going particle properties and then saying position. Now here's where there's a little trick that you need to know. It's also in the documentation. It's not like a trick, but this is just a particle. You can see this is just a particle property object. So there are two ways you can access the actual data. The first is .array, and this will give you a read-only view of the array, so a read-only view of the positions of all your particles. The other way is with marray, and this one you can actually modify. But remember, if you're going to make any changes to your system that you want to actually affect your system, you should be making those changes to the output. So in other words, you would say output.particle properties position marray. And then we could get, for example, we could say we want the first, the position of the first particle, and so we could do something like that. And there it is, the position. So that's basically particle properties, and particle properties are anything that is defined on a per atom basis. So you see right now we just have the identifier and position, but if we were to go in here and add, for example, a centrosymmetry parameter modifier, then when we look in here, we see we also have centrosymmetry. Also notice that as soon as I added a modifier before the Python script modifier, it updated automatically. And that's because every time something changes here, it's going to run this modify function, and so that'll be updated automatically. So you could also get the centrosymmetry in the same way. Now, so those are the per atom data that you might have in your system. The other type of data is what they call attributes, or this is your global values essentially. So you get them in a very similar way actually. We're going to look at attributes, and then we're going to look at the keys of that, because you're going to access them the same way you would a particle property. So you can see right now, as far as attributes, we just have a source frame and a time step. So this source frame should be the same as this frame here actually, and then time step just references whatever time step that happens to be. So in this case, if we print input attributes time step, you'll notice that we don't need to index this with anything else, or we don't need to use array or marray. We don't need to do that on attributes because there's only a one value associated with it. So if we hit the run button, we can see that we're just printing that value. And you can also see that here. This is just a dictionary, and this key has just a single integer associated with it. So that's how you'll get the global attributes. Now there's actually some, I want to go over very quickly one use case you might have for the Python script modifier, because it's something that OVITO doesn't have built in, and that is saving some of your data, as far as saving text files or data files that you can use in something else. So for example, we're going to close this for a second. let's look at this simulation a little bit. Go back to the beginning. We're going to add a polyhedral template modifier. We can see the FCC and BCC. And we're going to get rid of that center symmetry. Yeah. Okay, so we're just going to do that. And now we're going to open the script back up. So first of all, you can see we have a lot more per atom keys now. We have orientation, we have structure type, we have interatomic distance, we have color, and then in the attributes we also have polyhedral template matching counts for all these different kinds of structure types too. So that's actually really convenient. So what we want to do, I think, here, because basically as I'm running this simulation, I'm trying to see, this is copper, and so it's stable as FCC, but I have FCC and BCC. So I want to see, you know, if we can start to see this BCC transform into FCC. So then let's save the data for what percentage is FCC and what percentage is BCC throughout the simulation. So let's open up the Python script again, and looks like we can access how many, yeah, here we go. We can access how many FCC and how many BCC ones just by a key like that. So let's come up here, we'll say FCC count is input attributes, and I'm just gonna, oops, nope. Copy that in there. And then I'll say BCC count is going to be the same thing except for BCC. Okay, now I want to save this to a data file. So I'm going to say with open, oh, and one thing I found out while making this video, you need to use, in Windows at least, you need to use a full path to whatever file you want to make, because otherwise you probably get permissions error because it'll try to write it in the current directory, the working directory, which is most likely in the system files somewhere. So you don't want to do that, most likely. Let's see where I want to save this. And it looks like we're going to want to go and then we're going to write this, and we're going to write this as append plus. So that way, because this is only going to happen every time this is updated. So if we're writing it every time, then it's going to recreate this file every time, and we'll only have whatever the last time step that we ran it over was. So we want to append so that we get all the ones. But that also means that if we have to go back and restart or something, we need to go and delete this file manually so that we don't just append more data to old data that isn't correct. So anyway, we're going to do that, and then we're going to write a couple data points here. And we're going to write the time step, actually. So let me get that as well. Attributes, time step. So we'll write the time step, and then we'll write the fraction. So of BCC ones, and then the fraction, or FCC ones, and then the fraction of BCC ones. Move that down so it's easy to read. Okay. So I think that is going to do what we want. We'll see here. Nope. Oh, I have a spelling error in here. That'll do it. There we go. Now it wrote correctly. So if we open up that folder, we will see a data file. Now right now it just has one line. So we need to run this over the whole thing. So we'll start it there and then we'll press run. Now the unfortunate part about this is that you need to stop it right when it gets to the end, otherwise it'll restart and keep running data. But otherwise it works. Okay, so now if we look at that data file, reload it, now we can see we have the time steps all the way from 0 to 40,000. That's been a quick overview on how to use the Python script modifier and one small use case for it. I may make more videos on it in the future, probably doing something on one of the modifiers that I've actually made with it. But let me know in the comments if you have any questions or any suggestions of things to do with it. And I will see you in the next video. Thank you.